Hey guys, welcome back. Just had some pancakes. They were very good. A good old cappuccino. So, it's time to get OpenGL up in this. Where we have seen what GLFW has to offer and we want more. So, what's nice about Windows is that actually have OpenGL support kind of natively. So we can actually just include gl/gl.h and it's sort of already included in the Windows package. We don't need to download anything to use OpenGL. Kind of. Okay, we're gonna talk about it later. Okay. So if I compile this, it should just work. All right, cool. Our includes were accepted by the OpenGL or the Visual Studio Gods. So okay, how does OpenGL work? What's kind of nice and kind of a bit strange about OpenGL is that it's all global functions. OpenGL works on a global scale. All the functions are global calls, and so on. And what that means, if we have multiple screens, OpenGL needs to know, okay, which screen am I working on right now? Because it's global. It's like if we say clear the screen, it's just like clear the screen, and it needs to know which screen, and that's called a context. So OpenGL will have to know which context are we working on right now. So to set that, like this part is not the most important part. If you forgot this, it's fine. So we're gonna use the GLFW make context current. There it is. So here we're going to specify to OpenGL which window is the current context to work with. So when we're calling these global functions, OpenGL will know. We're going to clear the screen now, for example, so it will know which screen is actually to be cleared. So if we call some functions, we're going to call GL clear. All right, so GL clear is a function in OpenGL to just clear the screen. All right, and that is actually a little bit more complicated than you might think. There are multiple things to clear, like it might be clear the color, or clear the depth buffer, or clear the stencil buffer, and so on. And that's fine. We don't need to think about that right now. We'll think about it later. But for now, we just want to clear the color. So we're just going to specify GL clear. GL color buffer bit. All right, and what this means is that we want to clear the color buffer. All right, it's okay if that doesn't make too much sense right now. It will make sense later when we actually start talking about the other buffers. But right now we just want to clear the color buffer, and let's compile it. And unresolved external symbol imp gl cleared reference in function main. Okay, so we got a linker error. It's LNK stands for linker. So we are referencing this function gl clear that's been declared in the gl.h, but it's not defined. So what means is that we get this unresolved external symbol. I want you guys to take a second just to guess what's wrong. What have we forgotten to do? Like, what steps do we need to make from here? And if you've seen the optional video, what is linking, hopefully this should be quite clear. And the problem is that we are referencing the OpenGL library through the includes, but we're not linking with it. We're not linking with the OpenGL library. So all of these functions are not included in our exe or to our linker. So what we're going to do is that we're going to go into our project, our project properties, and then linker input additional dependencies. And we are linking with glfw3.lib, so that's cool. So I'm just gonna go in and edit this and also add opengl32.lib. I don't actually know why it's 32. I don't think there is a 64-bit version. I gotta be honest, I don't understand this quite correctly, why it sort of works with 64-bit, but all I know is that we got a link with opengl32.lib, and that's the magic word. So I'm gonna apply this, and then if we compile, now it works. So now it found the GL clear function inside the OpenGL 32.lib library. All right, tripping over my words. So let F5 this. All right. So a few things. I happen to know that GL clear should make the window black by default, so the default clear color should be black. And also if I do this, you can sort of see that, okay, it's not really looking like it's being cleared. It sort of looks like it's, you know, being a bit strange. Like if we're clearing, this whole thing should be black. No, I think that makes sense. So something's going wrong, and we have to take a step away real quickly to talk about an ancient problem with graphics drawing and graphics libraries, and why it's there and how we use the solution to that problem. So to do that, I thought the best way would be by example. So here's the game King's Quest for the IBM PC Junior back in the day. I think it was the 80s. So if we take a look, let's skip forward a little bit. So here it is, quite good, quite good looking. Here's the guy. I don't remember his name, Abram, I think. And let's see what happens when he transitions the screen here. So he's gonna walk to the left and transition to a new screen. All right, did you see what happened there? So what happened was the screen went completely white, and then each piece of the screen got drawn in one at a time. All right, so sort of you can see the computer sort of drawing one piece at a time, making the screen come forward. And this is just the way drawing, you know, this is what you expect. If I say draw a line on the screen, I expect a line to show up, and then if I say, oh, draw another line, then I expect the other line to come up, and that's sort of how they worked back then, and that made sense. But of course, it means that if I'm supposed to draw something that's quite complicated, it's gonna take a while. You know, the computer can only run so fast. So what's gonna happen is that you're gonna see each line pop in, and it's trying its hardest to do it as fast as it can. But in the end, we're gonna see this transition from going white to going to a full picture. And you know, that problem didn't go away. Like, you know, obviously our computers are way faster now than they are back then. But you know, we're also drawing way more complicated stuff. So if you think about it, if I also draw a scene, you know, in Unreal, they are lucky here that they can, you know, sort of draw it once and then have just the character superimposed on that, and the background can stay where it is. They don't need to draw the background every frame. But you know, in Unreal Engine, if I want to turn my screen, like, you know, everything is gonna change. All things are gonna move around on screen, and we're gonna see them in a different perspective and so on. So that means we have to draw everything every frame. And if you think about what's gonna happen is, like, if I have a bunch of cubes, I'm gonna draw. I mean, I can't draw them all at once. I'm gonna have to draw one at a time. So I draw one cube, and so that's gonna show up on screen. Then I'm gonna draw another cube, and that's gonna show up on screen. And then I draw the landscape and maybe the weapon, and they will all pop in on screen, you know, in order. So it might go very fast. Like, you know, it might just take a fraction of a. Might take even a, you know, fraction of a second, like a few milliseconds. But what's gonna happen is that it's gonna flicker. Like you as a player are gonna see a very you're gonna see very clearly the screen is flickering. You're gonna see it go black, and then it's gonna see like stuff popping up, and then it's going black again, and then stuff popping up. It's going very fast, but you can still perceive it. It's very uncomfortable. And you know, that was a problem back then. So how do we solve that? Well, we can look at how the Amiga did it. So here's the same game, King's Quest. Okay, let's just get rid of that. And let's see how they did it. So here's the same scene here. It's looking a little bit better. And here, Abraham, or whatever his name is, going to go to the left here. I think his name is Graham, actually. Oh, there we go. So what happened? So you see the game freezes for quite a long time. And then it sort of fades in, the same scene, it fades in. So what's happening there? Well, undoubtedly some of it's going to be a bit of loading time. But what I think is actually happening behind the scenes here is that it's doing the same thing. It's drawing the scene, line by line, filling in shapes and so on. But what it's doing is it's doing it on a separate texture. It's not doing it directly to the screen. It's actually drawing to a hidden texture used in memory. And then it's fading that texture into the screen. So you get this a little bit more pleasant fading effect. So that's why it takes so long. It still takes quite a while to draw out this line and fill in the pixels. So that's what this loading time is. This loading time is actually drawing stuff in the background, but it's just not showing up on screen. And this is how we solve it in the modern time as well. That instead of drawing directly to the screen and getting this flickering effect, we instead draw to something that we call a backbuffer. All right, so let's go into Paint. So bright. Get out of here. There we go. All right, so we're drawing to something called Backbuffer. You know what? I have a drawing pad. Let's just use it. I don't know why I'm so used to just drawing with the mouse. Okay, so let's see. So we have something called the Backbuffer. All right. And this is such a common solution, and it's such so accepted and embraced that this is by default the way Windows handles it for just regular programs as well. Everything graphically is always drawn to a backbuffer. So what that is just a texture that's the same dimensions as the screen, and that's where all the action happens. That's where we draw the cube. And we draw, that's a honking piece of cubage. And then we draw the landscape and a little mountain here and, clouds and all of that stuff. We're drawing it to the backbuffer, which is the texture in memory. But the screen stays completely blank. So if this is a screen, right, it's just nothing there. It's just completely blank. And then what happens is that at the end of the frame, when we've drawn everything to the backbuffer, and we're confident that this is the way we want it to look, we swap these two textures around. So instead of this one being sort of the active screen, the one that the player is seeing, we swap it so that you look at this texture now instead. So the screen was sort of, you can almost see it like cards, we're moving the front card to the back card to the back, so that you're seeing the front. So now this is what you're seeing. And what happens then is the next frame, we draw the next frame on this texture. So we swap which texture we're drawing to. And then it's okay, we're moving the camera a little bit. So the cube goes a little bit to the right. And the mountains are going a little bit to the right. And it's oh, who's this? It's a person. Wow. Maybe I'll shoot him. He's hey, he's talking to us. And then it's the clouds. Meanwhile, the player is staring at this screen. Seeing nothing changing. And then at the end of the frame we do the same thing, so we swap these two around. So now instead of looking at this one, instead of looking at this texture, now the player is looking at this texture, and it's just an instantaneous change. It's just like flipping a book. And then the process starts again. We clear this screen and we start drawing on there. So we sort of flip back and forth between these two textures. And the active texture is called, I actually don't know what the active texture is called, but I know what the inactive texture is called, the backbuffer. So the backbuffer is not just one texture, is actually just the current backbuffer texture. It changes between each frame. All right, so hopefully that makes sense. Oops, bang it out of here. So this GL clear, I mean, as long as I haven't messed something else up, is working just fine. It's clearing. It's just that it's clearing the backbuffer, and we're never telling the program to swap the buffers around. So it's just continuously clearing the backbuffer forever. So the way that this is handled is that in every context API or in Windows API, there is some sort of swap buffer function, and what this function does is doing this changing which texture the screen should be rendering. So we'll call glfw swap buffers, and then we'll set the window there, or we'll pass in the window as an argument. And now if we play There we go, now it's black, so now it's not white anymore. And if I draw it around, it's a little bit weird when we're dragging it, because when we're dragging it, it sort of gets stuck in this polyvents function. But then as soon as we let go, it gets sort of re-cleared again, like that. Very cool. So what if we want to clear it to a different color? Well, OpenGL has a very neat function called GL clear color. And it's important to note here, GL clear color does not actually clear the screen. It actually doesn't do anything visual. All it does is set what current color should be used when we're clearing the color buffer. So if we forget to do this clear, nothing will happen. So it takes 4 variables. It's the red, green, blue, and an alpha. And it sets the color buffer to be this color. So let's just make it a nice blue. I'll do 0.8. I set 1 as alpha. It doesn't really matter, but so let's see what happens. And there we go, a nice deep blue. Very neat. And again, if I were to comment this out, this is a common pitfall that people can fall into, me included. It's just black. Yeah, and actually does get cleared. That's interesting. I wonder if that's a quirk of GLFW actually, that when you swap the buffer, the back buffer gets sort of automatically cleared. That could be a thing, but it certainly is not OpenGL clearing the screen because it's black and we're setting the clear color to be clearly not black. So important note, GL clear color does not clear the screen, it only sets the color when we do clear. So always remember to have that in. And there we go. Very cool. And that's it. Let's start doing some cool stuff in the next video.